Dr. R. Sugurat Samuel is working as professor in physics in SRM University, Chennai. He is also training students for IIT JEE, AIEEE, and BITSAT. He has more than 16 years of academic experience both in teaching and research. He has published a book titled The Complete Handbook of Bachelor of Electronic Science Practicals. It is prescribed book in the syllabus for BSc Electronic Science by University of Madras. He has attended and presented papers in several national and international conferences and conducted many training programs and workshops. He has experience in both regular classroom teaching and also online teaching. His research areas are ultrasonics, polymers, crystal growth, and photovoltaic systems.
Welcome to UGC lecture series on Applied Sciences Electronics. We have been listening to a series of lectures on the subject Electricity and Basic Electronics for the BSc Electronic Sciences degree program. This paper is the first paper in the first semester of the degree course. This lecture is the 47th lecture in the series. In this lecture, we are going to learn about the different parameters related to transistor. And as a continuation to the last lecture, we have to start the H parameter in this lecture. Before we start the lecture, let us see today's session outline. In this session, we are going to see the transistor as a two-port network. Transistor parameters, namely Z, Y and H parameters, and then different H parameters and the significance of different H parameters. In the last lecture, we have concluded with the concepts related to the simplification of the transistor circuits. We learnt about the frequency response and the reason for the frequency response curve with the trend of lowering the gain at a lower frequency, increasing gain at the middle frequency, and then falling gain at the higher frequency. For understanding that with the equivalent circuits, we need to equip ourselves with certain terms. For that, we need to learn about the two-port network concepts. Transistor is a two-port device. We have seen why the transistor is called a two-port device in one of the previous lectures. It has got two input terminals and two output terminals. Any two-port network will have these terminals in the circuit. A transistor could very easily be recognized as a two-port network because it has two input and two output terminals separately. Because of the restriction, only three terminals are available in transistor. We need to maintain one terminal as a common terminal for both the input side and the output side. Because of this, we have three types of connections, three types of modes: common base mode, common emitter mode and common collector mode. All these are now familiar to us. Now, we will strengthen our understanding by learning the mathematical treatment given to a two-port network. We will then try to map this mathematical model with the actual transistor, and then the analysis of circuits will very much be reduced and it will be enhanced also. So, let us take up for our discussion the transistor as a two-port network. The equivalent circuit of a transistor can be drawn using simple approximation by retaining its essential features. These equivalent circuits will aid in analyzing transistor circuits easily and rapidly. So, this tells us the reason why we should try to have an equivalent circuit for a transistor. It will enhance our simplification technique. So, let us now take the transistor as a two-port network. A transistor can be treated as a two-port network. The terminal behavior of any two-port network can be specified by the terminal voltages V1 and V2 at ports 1 and 2 respectively, and current I1 and I2 entering ports 1 and 2 respectively as shown in the figure. This is representing a two-port network. It is a block diagram. We have the input current and the output current entering the network on either side, the input and the output side. Similarly, the voltage drop across the input terminals and the output terminals are also taken as these symbols V1 and V2. For currents, we have I1 and I2. Now, we have four variables, namely I1, V1 on the input side, I2, V2 on the output side. We can do lot of mathematical operations with these four variables. The way in which we take the variables decides what type of parameter we are dealing with. We can have any two as the dependent variables and other two as independent variables, but the variables are of our choice. Because of this flexibility, we have lots of transistor parameters. So, transistor parameters are decided by the way in which we take the variables for mathematical treatment. There are few quite familiar or famous parameters. Let us see what are those parameters. Of these four variables, V1, V2, I1 and I2, two can be selected as independent variables and the remaining two can be dependent variables on those independent variables. This leads to various two-port parameters, out of which the following three are more important. Z parameters, or it's called impedance parameters, then Y parameters or admittance parameters, and a quite famous one which is the H parameter or hybrid parameters. These are the commonly used transistor parameters Z, Y and H. Apart from that, we have S parameter, T parameter, etc. When we take up the pure electronics as a hardcore subject for our study, then treating the transistor in a mathematical way will become very significant in the study. At that time, we will take up different parameters because each parameter has its own advantage. But for this course, let us restrict our discussions to the H parameter. But when we take up only the H parameter, we may not be able to understand why the H parameter is significant for us. So, we will just have a look at the other parameters too and then take up the H parameter for our discussion. Let us see how much we could cover today. My aim is to deal the H parameter term by term exhaustively. I think today we will be able to do that. If we are not able to cover the H parameter fully, we will take it up for the exhaustive discussion in the next lecture also. So, let us start with these parameters, three parameters which we have highlighted now. The Z parameter is called the impedance parameter. What are the variables taken as independent and what are taken as dependent variables? So, let us take them up for our discussion. Z parameter or impedance parameter. In Z parameter, the V1 and V2 are dependent variables and I1 and I2 are independent variables. At this juncture, I would like to mention one important mathematical representation. When we write a function, on the left hand side, customarily we take the dependent variable, and on the right hand side we take the independent variable, that too as a function of something. So, we will show them as f of y is equal to f of x, for example. In that, y is a variable which depends on x. So, y is taken on the left hand side and x is taken on the right hand side within bracket. So, f of x, we write that as a function of x. The same way here also we need to take 2 as dependent and 2 as independent. So, independent variables will appear on the right hand side within bracket and dependent variables will appear on the left hand side as like y in the expression y is equal to f of x. So, let us see the 2 dependent and 2 independent variables which we have chosen for formulating the first parameter, which is Z parameter. Let us have a look at the expression. As I said, the V1 and V2 are independent variables here. So, they are taken on the left hand side. They are the functions of the current values I1 and I2. I1 and I2 are called now the independent variables. Similarly, we have written one expression for the V2. So, these are the 2 dependent variables. They depend on the independent variables I1 and I2 represented like this. Now, we can take the partial derivatives of these functions and try to find out the dependence factors. The left hand side term, how it depends on the right hand side term. If you want to independently find the the relation, we need to differentiate and then find the terms. But for that we will normally do using the Taylor's expansion or Taylor's series. That mathematical part will consume lot of time. So, I would like to reserve that mathematical part for the upcoming lectures. But right now, I would like to give it as a factual information and try to highlight the parameters, because this lecture is purely devoted to the different parameters alone. So, I would like to highlight the parameters and the mathematical part we will see later. Now, if the expansion is restricted to 2 terms, we have this expression for Vi and for V2, and it clearly shows the Vi depends on I1 and I2. The dependence factors, or we call them as quotients, are represented as Z11, Z12, and for the second equation it is Z21 and Z22. When we have a look at this equation, it is reminding us of the simultaneous equations. These equations could very well be represented in the matrix form also. I have shown you one equation. That equation has the 4 Z parameters. So, let us have a look at the equation once. In this equation, we have the 4 Z parameters appearing: Z11, Z12, Z21, Z22. These equations, as I said, could be represented in matrix form, that we will take it up for next lecture. But what are these Z11, Z12, Z21, Z22 terms? They are the parameters. Let us see the importance of them. We get the various Z parameters when we get rid of the one term in one equation at a time. So, in the first equation, when we take the I2 as 0, then this equation could be rewritten for Z11. It is taking the form V divided by I. We know what is V divided by I. It is nothing but the impedance. So, it has got the significance because it is representing the input impedance. Vi is on the input side, Ii is also on the input side, or we call it as port 1. So, it is representing the input impedance when the I2 is 0. Similarly, I would like to just show the forms how do we get. In the second equation here, Z12 is taken by considering the I1 0. Similarly, the same treatment is given for the second equation by taking I2 0 and I1 0, we get the different Z parameters. What is the meaning of taking the current I1, I2 as 0 values for obtaining the various Z parameters? When current is made 0, that particular section is called open circuited section. When a section is open circuited, the current will not flow. That means it's open, it's broken, that part. So, current won't be continuously flowing. So, we call them as the open circuited conditions respectively. These are some of the technical terms we use for analyzing the circuit. When I1 is 0, we call the input side is open circuited. When I2 is 0, the output side is open circuited, like that. So, these are the terminologies we use. So, by imposing these conditions, alternatively, we can find out the various Z parameters. Why the Z parameter is called the impedance parameter? Because all the Z parameters have the V divided by I form, which is nothing but the impedance or resistance. The other name we give in the electronics that we study here is impedance. So, we call them as impedance parameter. Now, we have one more parameter, in that the variables are to be taken in a different form. That is called the admittance parameter. In that, we will have I divided by V form. That parameter is called the Y parameter. Let us now see what is Y parameter. In Y parameter, the dependent variables are I1 and I2, and V1 and V2 are independent variables. Now, this form of writing the equation is quite familiar for us. So, I would like to skip how do we write this equation and all that, but the equation is now having a form I1 and I2 appearing on the left hand side and V1, V2 are on the right hand side, which implies the V values are independently varying and I is dependently varying factors. As we have done in the previous case, that is Z parameter, here in Y parameter also we can try to find out what these factors Y11, Y12, Y121 and Y22 mean. Let us now have a look at the representation of these individual parameters, which are called Y parameters. In Y parameter, we need to consider the voltage 0. In the first equation, when we take the V2 as 0, then we get an expression for Y11. And as I have discussed in the previous case, we need to take the V10 to get Y12. It is repeated for the second equation also. And the key point to be kept in mind is, in the case of Y parameter, all these expressions, Y expressions have I divided by V form. What is the meaning of I divided by V? It is nothing but the inverse of impedance. For inverse of impedance, we have a special name, it is admittance. So, this Y parameter is also called admittance parameter. We can have a relation between the Z parameter and the Y parameter, because when we take even for just a sample, I would like to mention, in the case of Z11, it is V1 divided by I1, and similarly in the case of Y11, it is I1 divided by V1. So, it is inverse of the other. Similarly, each parameter we have in Z form could be related to the Y form. These will enable us to have some sort of analysis of circuits. When we find one value, finding the other value in the circuit analysis will be very much easy when we have this relation among the different parameters. So, this has given us some idea about the parameter that we consider in the case of transistor. Now, let us take up the main parameter, that is the H parameter. What are taken as dependent variables and what are taken as independent variables in H parameters? Let us have a look at that. In H parameter, we have V1 and I2 as dependent variables. On the other hand, I1 and V2 are taken as independent variables. So, here we have these equations written. We have taken one I, that is I1, and one V, that is V2 as the independent variables, and the respective two, the remaining two as the dependent variables. So, this equation clearly gives us an idea. And here also, by taking the partial derivatives, we can write these functions in this form. So, we have the 4 H parameters, H11, H12, H21 and H22, they also have the significance. So, here we need to clearly understand what these H parameters mean, each H parameter means. So, let us take up for our discussion the 4 H parameters. By taking V2 0, when we simplify it for H11, we have V1 divided by I1, which is the input impedance. Here the V2 is made 0, which I forgot to mention. In the case of I maintained 0, the circuit is called open circuited. When the voltage is made 0, it is called short circuited. We need to connect the two terminals without any resistance in between. In that case, the voltage drop will be 0. So, it is called short circuited condition. So, these points we need to keep in mind. Open circuited, current is 0. Short circuited, voltage is 0. So, these terminologies we use here. So, with the output port short circuited, that is V2 is 0, we have H11. Similarly, if you want to get H22, the input is open circuited, so current becomes 0 and it is called output admittance. Now, we know the impedance, output admittance, what they mean. And the H12 is obtained by taking I10 in the previous equation that we have written. It is called the reverse voltage transfer ratio. It is written as V1 divided by V2. It is also called the voltage gain, but in a inverse way we have taken. When we call that as a gain, it is V2 divided by V1. Any gain is output divided by input. But here what appears, it is V1 divided by V2 comes. So, we do not want to call it as gain, but we call it as the ratio. Even we can call it as a gain with the additional term, the reverse voltage gain. That terminology we can use, but those points we will see when we take up H parameter for exhaustive discussion. And now, let us see the last hybrid parameter, what it is. The H21 is obtained by taking the V20. What is the meaning of V20 gain? The output part is short circuited. So, it is called the forward current gain. It is I2 divided by I1. So, we have seen the importance of the parameters, especially the H parameter. In H parameter, each parameter has a different form. We have V divided by I form, I divided by V form, then I divided by I form and V divided by V form. Of course, the suffixes are different. So, what is the meaning of the different forms that we have? I think that is why the name hybrid is given. We have all the forms of expressions appearing in H parameter. Let us now see the dimensions or the units of these parameters. H11 is in ohm, H22 is in ohm inverse, which is called mho. H12 is a dimensionless quantity, which is the voltage ratio. H21 is again a dimensionless quantity, which is the current ratio. As the dimensions are not alike, they are hybrid in nature, and these parameters are called as hybrid parameters because of this mixed forms that we have. So, we have got an idea why the H parameters are called by the name H or hybrid parameter because of the different forms appearing. Now, let us see the significance of H parameter, how they will be useful in circuit analysis. And this is again the typical terminologies we use. The 1 when it comes, it is input side, so it's called, we attach the word input to it. 2 when it comes, it is called output. 2 when it comes, it is called forward transfer, and 1 when that suffix comes, it is called reverse transfer. And of course, these points I have already highlighted. The H11 is the input impedance, H22 is output admittance, H12 is voltage transfer ratio, and H21 is current transfer ratio, of course with the other terminologies like forward, reverse, input, output, etc. And one more condition, whether it is because of the short circuit or open circuit conditions. We have seen the different hybrid parameters. These hybrid parameters are of very significant to us for circuit analysis. I have rushed through the H parameters so that we could have an idea of H parameter in this lecture, but how this H parameter could be used for drawing an equivalent circuit for a transistor. That is the main aim of studying all these parameters. And the open circuit condition, closed circuit condition, these we need to learn with little more understanding. So, I would like to continue with the discussion on H parameter in the forthcoming lecture. We will see how a transistor could be quickly represented as an equivalent circuit with the help of the H parameters. So, I would like to wind up the session at this point, and let us see the session summary of today's lecture. In this session, we have seen the transistor as a two-port network. We have seen transistor parameters, especially Z, Y and H parameters, and then we learned different H parameters with the meaning of each H parameter. The significance of H parameter we will take up for the next lecture. Before we wind up today's lecture, let us test our understanding by answering these questions. What is a two-port network? What are the different parameters of transistor? Explain the different H parameters of transistor. We will continue with the concepts of H parameter and the simplification of a transistor into a equivalent circuit in the next lecture. Thank you for listening.